Here's sample test number 1, problem number 4. An object is thrown downward with initial speed of 15 meters per second from a height of 60 meters above the ground. At the same instant, a second object is propelled vertically upward from ground level with a speed of 30 meters per second. At what height above the ground will the two objects pass each other? Good question. So here's our situation. We have somebody throwing an object down, and this total height right here is 60 meters. And they're going to throw this down like this. So for object number 1, we're going to have an initial speed of 15 meters per second. And we're going to define that direction as our positive direction. So that would make our acceleration a positive 9.8 meters per second squared, because that's already in the down direction. And that makes sense because it's going to speed up the ball as it's going down. So it's going to be a positive acceleration. And our displacement, we don't know yet, because it's going to go down some displacement. We don't know, let's call it delta y1, to some height here, like this. So we don't know what that is yet. What else do we know? We don't know the time. So t1 we don't know. And we don't know our final velocity. Okay, so that's for object number 1. We have another object that's being thrown straight up. And so this is going to have initial velocity that's going up. That's our positive direction there. Our initial velocity there is 30 meters per second, positive. But then our acceleration for this one is going to be a negative 9.8 meters per second squared. And our displacement, we don't know. It's going to be up like this. And we don't know our time. And we don't know our final velocity. Based on what we have here, and the first information is our first displacement, delta y1, is going to equal our initial velocity times time plus 1/2 acceleration times time squared. And so we're going to have that delta y1 is equal to 15 times t1 plus 1/2 times 9.8 times t1 squared, or 15 t1 plus 4.9 t1 squared. We also have that delta y2 is equal to our initial velocity for that one, t2 plus 1/2 acceleration t2 squared. Always nice to start off with your algebraic equation first. This is going to be 30 t2 plus 1/2 times a negative 9.8 t2 squared. And this would be 30 t2 minus 4.9 t2 squared. Nice. Well, we know that these two displacements are going to equal 60, because if you add delta y1 as a positive value plus delta y2 positive value, that will traverse the whole height of 60 meters. We also know that t1 is equal to t2 is equal to t, because they're both simultaneously thrown. So let's say that all of our times are just t. Hence, if we have delta y1, we're going to have 15t plus 4.9 t squared plus delta y2, which is 30t, minus 4.9 t squared, equals 60. Well, our 4.9 t squares cancel out, and we are left with 45t equals 60, or t is equal to 60 divided by 45, which is going to be 1.33 seconds. Sounds good? But we want to find out what height above the ground the two objects pass each other. That indeed is really going to be our delta y2 that we want. And delta y2 is equal to 30t minus 4.9 t squared. So in this case, that's going to be 30 times 1.33 minus 4.9 times 1.33 squared. And that is equal to 31.3 meters. So these two objects will pass each other 31.3 meters above the ground. And that will be the point above the ground that the two objects pass each other.